Assalamu alaikum. Hi, this is Mr. Khalid Abdulzahir from Cairo, Egypt. Welcome back to our sessions about the organic chemistry. Today we are going to study or discuss how to express the compounds. Compounds are expressed by what is known as chemical formula. Chemical formula here may be molecular formula or structural formula. The molecular is the simplest one because it shows only the type and the number of atoms in the molecules, like CH4, C2H6. This is only an indication about the number and type. But when we are talking about the structural formula, it gives us more details about the molecule. Why? Because it talks about or it shows the arrangement of the atoms inside the molecule, and also it shows the type of bonds between atoms, like this case. Look, for methane, C is surrounded by 4 hydrogen atoms and the bonds are single bonds. 4 bonds are single bonds. Why 4 bonds? Because carbon is tetravalent and the hydrogen is monovalent. In the case of ethane gas, you will find the formula C2H6, the two carbons linked together by single sigma bond and also surrounded by hydrogen atoms, but each carbon attached to 3 hydrogen. Why? To compensate or to give us its exact valency, which is tetravalent also. So the carbon must be surrounded by 4 dashes, each dash composed of 2 electrons. So this is the valency of carbon. Don't forget, valency of carbon is tetravalent, but hydrogen is monovalent. Also, you can find another formula like urea, like acetic acid, the molecular formula, and below it you will find the structural formula for each of them. You will find that in case of carbon, the central atom in urea attached by double bond with oxygen and a single with nitrogen. Why? Because carbon must be surrounded by 4 dashes, as we said previously, but oxygen is divalent, so it must be surrounded by 2 dashes only. Nitrogen, don't forget this, nitrogen is trivalent atom, so it is surrounded by 3 dashes. You can find them and you can count them. There are 3 dashes surrounding each nitrogen, 1 with carbon and 2 with 2 hydrogen atoms on both sides of the carbon. In acetic acid, you can find that the first carbon attached to 3 hydrogen and the fourth bond with the carbon, but the second carbon attached with the oxygen by double bond and the left carbon by sigma bond and the right oxygen with the only sigma bond. Why? Because O is attached from the other side with hydrogen. Okay, so you will get that the number of bonds surrounding carbon must be 4. The number of dashes or bonds surrounding oxygen must be 2. The number of bonds surrounding hydrogen must be 1, but nitrogen must be 3. So this is the preferable form of the structural formula. So why structure is more preferable than molecular? Because it gives us details about the structural formula of the compound. Let's go to another point, which is exercise. Illustrate the structural formula for the following compounds, and I will give it to you. I will leave it to you to answer this table and send me this table on the Facebook. You can follow me on Facebook on a page called Let's Ask Mr. Khalid. Another point which is very important, which is called isomerism. Isomerism means a characteristic only of organic compounds having the same molecular formula, but they differ in the structural formula. They differ also in physical and chemical properties. Like this, you can find this chemical formula C2H6O. This is molecular formula. But if we go to the structural formulae that we can get from this molecular formula, they are too structural. The first of them is common for us, which is called ethyl alcohol or ethanol, C2H5OH. The structural shape here differs than the other compound on the right side, which is called dimethyl ether. Dimethyl ether composed of central oxygen surrounded by two carbon atoms, each of them attached to three hydrogen atoms. So CH3 on the left side, CH3 on the right side, and O at the center between them. This is called the dimethyl ether. There are many differences between these two compounds. They are two isomers. They are different in structural, as you see on the board. Also, they are different in the physical properties and the chemical. Physical, like what? Like the boiling point. Alcohol has a higher boiling point than ether. Also, the reactions. Alcohol react with sodium metal, and this reaction producing hydrogen gas. You can observe it obviously. But on the other side, dimethyl ether, it doesn't react with sodium metal. Okay, so this is called isomerism property, and we can get more than one structural formula from a definite molecular formula. This is exercise for you. Draw the possible isomers of this formula C5H12. You can send the answers to Facebook, a page called Let's Ask Mr. Khaled. Don't forget to subscribe. Don't forget also to like and share. Another point which is very important, how to detect the main elements. We said that organic compounds are composed of carbon and hydrogen. Really? So how to test the presence of these two elements, carbon and hydrogen? They present in most of our compounds, daily compounds, like what? Like paper, piece of tissue, textile, piece of bread, piece of cotton. How to know the presence of carbon and hydrogen? We will go to do this experiment. Heat the organic substance with black copper oxide, has the chemical formula CuO. Don't forget, copper in this formula is divalent and oxygen also is divalent. Put them in a test tube as shown in the figure. Heat them strongly and allow the gases to pass over a white copper sulfate. Copper sulfate has white color, but it can be changed into blue. How? When water vapor passes over it, it will absorb water vapor and change it from the white color to blue color, and this will happen. Also allow the resulting gases to pass through lime water, which is calcium hydroxide, CaOH by 2. Lime water is clear, but after passing a definite gas, it will become turbid. What is this gas? Do you know it? Excellent. Yes, this is carbon dioxide gas. So, the observations and the conclusion, copper sulfate turns to blue. This is the first observation, indicating the presence of water. That's to say, the organic compound contains hydrogen, which reacts with the oxygen from copper oxide to form water vapor, and the copper is remained. The second observation, lime water turns turbid, indicating the presence of carbon dioxide gas. That's to say, the organic compound contains carbon, which also reacts with oxygen from copper oxide and producing carbon dioxide gas, and the copper is left. So the final conclusion is the presence of carbon and hydrogen in any organic compound. Thank you. I wish you good time, and don't forget, subscribe, like, and share. Goodbye.